Alright, thanks for watching. Here we are going to do a super cool integral, and that's the integral of 1 over sine to a 6 power x plus cosine to a 6 power x. As always, please pause the video and try this first. Okay, hopefully you guys have a chance to try it. And before we continue, please subscribe to my channel if you haven't done so already. Thank you guys so much. And also, you notice that this right here seems really difficult, right? Yes, it is really difficult because otherwise I wouldn't want to do this video, but it's okay, we can do it together. Anyway, here we go. Notice on the denominator, this right here is technically the sum of two cubes because we can look at this as sine squared and then raise that to a third power. Likewise, this as cosine squared and we raise that to a third power. And with that said, we can actually factor out the denominator. And let me just put this down on the side for you guys for the algebra part. Once again, I will look at this part as sine squared x, and then we raise that to a third power, and then we add cosine to the second power, and then we raise that to the third power. And here we go. For the first factor, we pretty much have this plus that, and this is so wonderful because we end up with sine squared x plus cosine squared x. And this is just equal to 1. And by the way, in Chinese, 1 is E, okay? The pronunciation, E. Yeah, we already know like this, but it's okay. All right, and then the second factor is you have to square this guy. Let me put this down like this. Sine square x and then square, and then I will have to minus this times that, which is, of course, just sine square x times cosine square x. And lastly, we are going to add this to the second power. So I will put this in parentheses, cosine square x, and then raise that to a second power, and then right here, that's the factoring. Once again, this right here is just equal to 1, so perhaps I'll just indicate that right here for you guys. So that's good. Now we are pretty much just going to focus on that. But I will not put this down to the denominator because if I do that, the integral will still be intimidating. In fact, we are going to do a little bit more right here. And this is how. Notice that this is pretty much in the form of a squared plus b squared, but right here in the middle, it's unfortunately just minus ab. I wish to have minus 2ab so that I can continue to factor, isn't it? Yes, it is. So this is what we will do. I will look at this right here, and I will just purposely write this as sine square x to the second power, and then I really want to have a minus 2 instead of a minus 1 right here. So let's put down minus 2 right here. And of course, I still want to have the sine square x times cosine square x, and lastly, plus cosine square x, like this, and square. But the problem is that this is not the same as that anymore, but it's okay. We can fix it by doing, just add one of these back. So we just need to add sine square x times cosine square x. This combined with that, we still end up with that. So this is wonderful. And now we can continue. Because for the first three terms right here, we can factor it. And let me just indicate that right here for you guys. This is going to be sine square x. And then this is going to be a minus cosine square x. And then we have to square that. Cool, huh? And then we are going to add this right here. It's sine square x times cosine square x. Of course, we can just put this down like this. Parentheses square with sine x, cosine x inside. So this is wonderful. And now, can we do more? Yes, because notice this right here, we actually have an identity for that. Well, if today you have cosine of 2x, this right here gives you cosine square x minus sine square x. Technically, right here, it's just the opposite, right? This is reverse. So I just have to multiply by negative. So this is good. Take that square, and can we do something with this as well? Yes, because this right here, we can use the double angle identity for sine, but I need a 2. It's okay. I will just have the 1/2 right here to help me out. I will put down 1/2 times sine of 2x like that. And because once again, if you put a 2 right here, just divide it by 2, that's how we get the 1/2. And then 2 sine x cosine x give us sine of 2x. This is so wonderful. And now you see this right here is just going to be, that's going to be positive. So we have positive cosine square of 2x plus this is 1/4 sine square of 2x. Whew, yes. Now I feel better. Let's actually do some integral now. So we come back to the integral, and this is the same as the integral of 1/, this right here. So you have cosine square of 2x, and then we add 1/4 sine square of 2x. Like that, dx, of course. And now, clean things up a little bit. This is like a small complex fraction. We don't like that. Let's multiply the top and bottom by 4. Yeah, whichever way that you to do it. So I'll just put down a 4 right here. And then, yeah, seriously, it depends on how you want to do it. You can just multiply this by 4. And then multiply the top by 4. So if you do that, you can put a 4 in the front. Like this. And then the integral. And then you have the 1/4 times this is just 4 cosine square of 2x. 4 times that is just plus sine square of 2x. Yeah, like that. Okay. Why is this a 4, man? If there is no 4, then that's just equal to 1. The life will be so much better. Let's see how we can deal with this. Well, this integral is in terms of sine and cosine. I don't think I can do any u sub at the moment. Maybe you see the u sub, let me know. Let me not deal with sine cosine. I'm kind of tired of sine cosine. It's okay because remember in integrals, tangent and secant, they also get along with each other really well. When sine cosine don't work, maybe let's change to secant and tangent. And to do so, in order to produce tangent, I just have to divide it by the cosine square, right? That's pretty much all I need to do. So let me do that. And I will just put this down like this. That's divided by, let's multiply by 1 cosine square x, like that. Well, technically, I will need to have the same angle. So it's cosine square of 2x. And likewise, I also put down 1 cosine square of 2x. And hopefully it works. Okay, let's see what this is going to give us. I still have the 4 all the way in the front. Integral. Let's look at this. This times that, I will just have a 4. And then this times that, I will have a tangent. So plus tangent square, and the input is still 2x. So that's excellent. Look at that. So that takes care of this. And now you see the tangent. The beauty is that on the top, 1 cosine square of 2x is just secant square, right? So this part, I will write it as secant square of 2x, like that. And of course, we still have the dx. And now what? Yes, do u sub. So from here, let me see if I have enough space. Perhaps I'll do the u sub right here real quick. Let u equal tangent just to the first power of 2x. And then differentiate this guy real quick. You get du equals differentiating tangent, we get secant square, and the input stays the same. But the chain rule says we have to multiply by the derivative of 2x, which is the 2. And then don't forget the dx right here. And now you see that this right here is pretty much the same as the du, but not quite, because I want to have a 2 right here, right? So what you can do is you can just put down a 2 right here. Let me just put down a 2 right here. And then divide it by 2, like that. So with all that, this will give me the du. And you will see that here we will have a 2, and then the integral. And on the top now is just du. But let me write it down later. I'll just put down 1 this is 4 plus u square. And then, as I said, du right here on the side, like that. Okay, cool. How can we integrate this? Yes, we have to use some kind of inverse tangent. So here we go. Look at the 4 as 2 square. So this is how we are going to do it. Let me just erase the 4 and put that as 2 square. And you have to remember that formula for the inverse tangent. So let me just put down the constant multiple 2 right here first, and then the integral of this will give me 1 over 2 times the inverse tangent of u over 2. Okay? And that's pretty much it. And the beauty is that the 2 and 1/2 cancel, so you get the inverse tangent of u over 2. And what's u? Yes, u is just tangent of 2x. And now we're done. Yes. So in the end, I will just write down the answer right here. So finally, I will just have the inverse tangent of 2x, and then divided by 2 right there. Right, all done. So put plus c like that. Okay? That's it. Hopefully you guys all like this video, and leave a comment down below and let me know if you guys have any questions. Alright, so once again, if you guys are new to my channel, be sure to subscribe. You guys can find a lot more interesting math videos on my channel. And thank you guys so much for watching. And as always, this is it.